Hey guys, this is Fangxin, or some people like to call me Brian. Alright, so what I'm going to do today is I'll be doing a simulation on Multisim Live for a second order low pass filter. So when we study the characteristics of a filter through simulation, what we like to see is two things. The first thing is what we call an AC sweep or an AC analysis, and the second thing is the transient response analysis. So I will show you these two types of simulation from my simulation circuit here. Alright, so this is my circuit, and I will do a AC sweep from 1 Hz to 30,000 kilohertz with my vertical scale in decibels. And there we go. This is my, and yeah. So this is my AC sweep. So what does an AC sweep graph shows? So basically, what this shows is two things. For it shows the magnitude body plot and the phase body plot. So what are these two? So a magnitude body plot basically shows the changes in voltage gain in terms of dB, decibels, across the range of increasing frequencies, which is from here I set it from 1 Hz to 30,000 kilohertz. And for the phase body plot, it shows the changes of the phase shift across all of these frequencies, and basically plots all these points on a single graph. So the main thing that we want to determine from a body plot is the cutoff frequency, where from my calculation for this circuit, which is about 1 divided by 2 pi RC, I get a cutoff frequency of 709 Hertz. So let's plot the point at that frequency. 708. Yeah, this is pretty close to 709. And yeah, this is the cutoff frequency, which from here what we can see is when the voltage gain is before the cutoff frequency, you can see it's at its maximum gain, which is around 3.94 Hertz, and slowly starts to decrease as it approaches the cutoff frequency. And after it passes the cutoff frequency, you see it drops dramatically, about negative 40 decibels per decade. And yeah, so this is the body plot shown by the AC sweep. So the next thing I want to show you is the transient response. So what the transient shows is we have an AC voltage with 100 Hz and 0.5 peak voltage value. So let's start our simulation. There you go, there you have it. So this is my the transient response, which shows how the input and output voltage waveforms change across time. So when we see here, the first cursor points towards my input, which is about close to 500 millivolts, which is what we set as the AC voltage, when my second cursor at about 780 volts, which means there is a gain, there is a small gain due to the RA and RB values here. And next I will do a quick comparison of 100 Hz and 10,000 kilohertz. So just to show you a difference. Alright, so obviously for a 10,000 kilohertz, there is a much more oscillations for the input. So I'll just try to focus it at a smaller value, and there we go, there we have it. So this is the transient response when it is at a 10,000 Hertz, which shows the V out value drops dramatically. And this is what we expect to see because this is a low pass filter. Low pass filter, logically it passes low filters and attenuate the output when the frequency is at a higher range, which high means like higher than the cutoff frequency. And there you go. There you can see the with the voltage output value with a very low value, and there you go. So this is the transient and AC sweep analysis for a low pass filter. And thank you, and see you again. Bye bye.